Some disasters do not come from nature. They come from bad decisions. A bridge that twisted until it fell into the water, a tunnel ceiling that crushed a car, a toxic cloud that swept over a sleeping city, a tower that started dropping glass from the sky. These are not just accidents. They are warnings. Today, we're counting down the top 9. Stay until number 1, because the final disaster looked like a beautiful engineering masterpiece, right before the wind tore it apart. Before we begin, tell us in the comments which disaster you think could have been prevented the easiest. Number 9. Artz Pedregal collapse. This luxury shopping mall was built to impress Mexico City. Then part of it collapsed under the weight of problems hiding beneath the surface. To be continued in part 2. Picture a modern shopping complex filled with high-end boutiques, polished concrete, glass, cars, and clean architectural lines. It sits against a hillside, looking expensive and secure. Then heavy rain pounds the city for days. The ground becomes saturated. Pressure builds. And suddenly, a large section of the rooftop parking area caves in, sending debris crashing down onto vehicles and lower levels. Artz Pedregal was completed in 2018 and was meant to serve wealthy residents in Mexico City. But on July 12th of that same year, part of the mall suffered a dramatic structural collapse. According to the source, the failure was linked to a combination of weak design and construction issues, heavy rainfall, hillside pressure, poor drainage, and inadequate water management. This is what makes the disaster so disturbing. A building does not only stand on its design drawings, it stands on soil, drainage, weather, slopes, and maintenance. To be continued. The collapse happened during a heavy rainstorm after Mexico City had already been hit by days of rain. The mall's hillside location made the situation worse because saturated ground can place enormous pressure on foundations. The most shocking part is that no lives were lost. That was not just engineering, that was luck. For the people inside, it was a terrifying reminder that beautiful architecture can still fail if water, foundation pressure, and construction quality are not respected. Artz Pedregal became a public example of hidden systems quietly failing. But if this mall collapse showed what rain can do, the next disaster happened in a place where thousands of travelers expected safety. From Mexico, we moved to China, where part of a new airport terminal suddenly came down. Number 8. Nanchang Airport Terminal collapse. Airports are supposed to feel like symbols of progress. This one became a warning about what happens when construction quality is compromised. To be continued. Nanchang Airport, located in Jiangxi Province, China, was an important transportation hub. But on August 4, 2019, a section of its newly built Terminal 2 suddenly collapsed. The source states that investigations pointed to compromised construction quality, including substandard materials and workmanship. Weather conditions combined with those construction flaws to create a dangerous situation. This is not the kind of failure people expect from a new facility, and that is why it matters. New does not always mean safe. The collapse happened during a less crowded time, which helped prevent fatalities. Several people were injured, and the terminal suffered major damage. That single detail changes the entire story. The difference between an engineering failure and a mass casualty event can sometimes be nothing more than timing. When a new terminal collapses, it damages more than concrete. It damages public trust. To be continued. Number 7. Tretten Bridge collapse. This bridge was expected to stand for 100 years. It failed after just 1 decade. On a normal morning in southern Norway, vehicles move across a quiet bridge made of timber and steel. No warning that the structure is about to give way. Then the bridge drops. A car plunges into the river. A truck is left balanced on a broken section of the fallen structure. The scene looks unreal, like the ground simply decided to disappear. The Tretten Bridge collapse raised serious questions about design, inspection, and maintenance. It had been designed as a blend of architecture and engineering, using timber and steel. But infrastructure is not judged by how elegant it looks on opening day. It is judged by how it survives real use. To be continued. Number 6. The Great Boston Molasses Flood. It sounds almost impossible until you realize how deadly 2.3 million gallons of molasses can become. Boston's North End, January 1919. A massive steel tank towers over the neighborhood, filled with dark, heavy molasses used in industrial alcohol production. Then, the tank fails. A thick brown wave bursts into the streets. It crashes into buildings, sweeps away vehicles, traps people, and moves with terrifying force. This was not a spill, it was a moving wall. The investigation found that the tank's construction had been subpar. Warm weather may have caused fermentation, increasing internal pressure. Poor maintenance and weak safety practices made the situation worse. To be continued in Part 7. Number 5. John Hancock Tower glass failure. This skyscraper was designed to reflect the city. Instead, it started dropping pieces of itself onto the streets. Large glass panes detach from the building. They fall hundreds of feet. Pedestrians below are suddenly living under a vertical hazard zone. The tower was completed in 1976, but large glass panels began falling. Boston's temperature swings caused the glass to move beyond what the design anticipated. In one case, a 500-pound glass pane crashed to the ground. Engineers had to remove and reinstall thousands of panels with a new system that allowed controlled movement. A building's exterior is not decoration. It is a system exposed to the environment. Even beauty can become dangerous when engineering underestimates nature. To be continued. From Boston's glass tower, we stay in the same city and go underground into one of America's most expensive infrastructure projects. Number 4. The Big Dig Tunnel Collapse. The Big Dig was supposed to fix Boston's traffic. Instead, one ceiling panel turned it into a tragedy. Below Boston, traffic moves through a massive tunnel system. Built to replace an old elevated highway, the city above has been reshaped. Roads, ramps, walls, tunnels, and ventilation systems form the structure. This is one of the most ambitious urban infrastructure projects in the United States. To be continued. Then, in 2006, part of the tunnel ceiling fails. Heavy panels come loose. One panel falls onto a passing car. A normal drive becomes a fatal engineering disaster. The Big Dig was plagued by delays and cost overruns. What began as a $2.8 billion project stretched over 2 decades and reached around $22 billion. The panels weighed up to 3 tons and were held by epoxy bolts. The epoxy fasteners were not adequate for long-term vibration and stress. Water leakage contaminated the system and further weakened the fasteners. A small fastening system hidden above traffic becomes the difference between safety and a fatal collapse. The tragedy triggered questions about oversight and quality control. The Big Dig became a symbol of how mega projects can fail through details that seem small until they kill. To be continued. Number 3. Bhopal disaster. The city was asleep when the gas began moving through the streets. Inside the facility, a storage tank holds a dangerous chemical. Systems meant to control risk are weak, disabled, poorly maintained, or not enough. Then a runaway reaction begins. Pressure rises, temperature rises. A toxic cloud escapes into the night. A tank containing 42 tons of methyl isocyanate. A heavier-than-air toxic cloud spread over Bhopal while thousands were asleep. To be continued. The Bhopal disaster happened at the Union Carbide pesticide plant. Methyl isocyanate was stored in a tank where water ingress triggered a catastrophic reaction. The plant had safety systems, but systematic negligence, cost-cutting, and inadequate maintenance broke the chain. This was not one mistake. It was a chain. A toxic cloud spread over Bhopal while thousands were asleep. People woke up choking. Hospitals were overwhelmed. Panic filled the city. Safety is not paperwork. Safety is survival. Bhopal triggered international outrage, legal battles, and questions about environmental justice. Infrastructure failures near vulnerable communities hit differently. To be continued. Bhopal shows what happens on land. The next disaster happened far offshore, where a safety device failed deep beneath the ocean. To be continued in Part 12. This disaster did not begin with oil on the water. It began with pressure that engineers could not control. Far out in the Gulf of Mexico, the Deepwater Horizon drilling rig stands over a deep reservoir beneath the seafloor. At night, steel decks glow under work lights. Pipes, valves, control rooms, and drilling systems operate in one of the most extreme industrial environments on Earth. Then pressure surges, gas rises, explosions tear through the rig. Fire consumes the structure. Below the surface, oil begins escaping into the ocean. The Deepwater Horizon disaster happened in April 2010. The rig was working over the Macondo prospect in the Gulf of Mexico. To be continued in Part 13. The disaster involved engineering misjudgments, inadequate safety measures, and the failure of the blowout preventer. The blowout preventer was supposed to seal the well in an emergency, but it failed. 11 workers lost their lives. The resulting spill became the largest marine oil spill in history. A negative pressure test was misinterpreted and dismissed. That detail is terrifying. A test designed to reveal danger became part of the path to disaster because the warning was not acted on correctly. Beauty can be dangerous when engineering underestimates nature. The oil spill devastated coastal communities, harmed marine life, and left a lasting mark on the Gulf. BP faced major legal consequences. Deepwater Horizon changed how we view offshore drilling. It proved that infrastructure can be far from shore and still affect millions. But number one is not an oil rig. It is a bridge that the world watched twist itself apart. To be continued. Number one is the Tacoma Narrows Bridge, the infrastructure disaster that turned a beautiful suspension bridge into one of the most famous engineering failures ever captured on film. It is November 7th, 1940. A long, narrow bridge stretches across the Tacoma Narrows. From a distance, it looks graceful, modern, confident. Then the wind begins to work on it. The bridge moves. At first, the motion seems strange but almost elegant. The roadway rises and falls. Then the movement grows. The center span twists. One side lifts while the other drops. The deck rolls like a sheet of metal caught in invisible hands. This is not how a bridge should move. Cars are trapped. Steel bends. The entire bridge becomes a wave. Then, piece by piece, it fails. Around 11 a.m., a large section of the center span broke free and fell into the water. To be continued. The Tacoma Narrows Bridge was built to connect Tacoma with the Kitsap Peninsula. Construction began in 1938, and by July 1940, the bridge stood as a major modern structure with a main span of about 2,800 feet. But the bridge had a slender profile and shallow girders. That made it vulnerable to aerodynamic forces. On the day of the collapse, winds reached around 40 miles per hour. The bridge began to oscillate violently because of aeroelastic flutter, a destructive interaction between wind forces and the structure's motion. In simple terms, the wind was not just pushing the bridge, it was feeding energy into the bridge's movement, and the bridge could not stop it. The collapse was filmed and photographed, which is why it became one of the most recognizable engineering disasters in history. To be continued in Part 16. Around 11 a.m., a large section of the center span broke free and fell into the water. Astonishingly, there were no human casualties, but the bridge itself became a global lesson. Engineers had to understand motion, airflow, vibration, and stability. Tacoma Narrows changed civil engineering, forcing a deeper study of aerodynamics in bridge design. The wind found the weakness not with fire or earthquake, but with rhythm and energy. Infrastructure fails because the world touches a small weakness until it gives up. From a mall in Mexico to a bridge in Washington, these disasters show an uncomfortable truth. When design, maintenance, and responsibility fail, concrete and steel become dangerous. Which disaster shocked you the most? Let us know in the comments. Subscribe for more rankings. In the next video, we'll explore the most dangerous megastructures ever built.